Hello there, welcome once again to our science lesson. In our previous lesson, we were looking at plant hormones. We said plants are also able to respond to changes in the environment, just like other living things. But we said that for plants, because they are less complex and less active, the way they respond is going to be different. The response is going to be slow and is majorly carried out by the influence of hormones. So we looked at two plant hormones that are very important in this case. We found out that we have a hormone auxin and a hormone gibberellin. Auxin is majorly involved in influencing cell division, or in other words, it stimulates cell division. In the process, cell elongation, which brings about growth of the plants. But for gibberellins, we were able to outline some of the influences in plants, and we realized that it has variety of functions in plants. We said that gibberellins are able to influence root growth. They bring about enlargement of leaves. Gibberellins also bring about fruit development and also flowering in plants. But the two hormones usually work synergistically. That is, they work in a synergy. In other words, they work together. But of the two, auxin is the most influential. And we realize that due to these hormones, they bring about what we call growth movements in plants, because the only form in which plants can respond to changes in the environment is through growth of their parts. It's either their shoots are growing towards or away from the stimuli, or it is the shoot growing towards or away from the stimuli. So these growth curvatures in parts of the plants, we were able to name them as tropisms. Tropism. So that tropism is the growth movement of the parts of the plant in response to an external stimuli. We were able to mention several kinds of tropisms. We looked at hydrotropism, response either away or towards water or moisture. So the stimuli here is usually water or moisture. We were able to find out that we also have geotropism. Geotropism, the stimuli being gravity. We also found out that we have phototropism. Here the stimuli being light. We found out that again, plants can respond to touch. That response is called thigmotropism, touch, contact. Contact. And then chemotropism. Response to gradient, to change in gradient or concentration of chemicals. So here, the stimuli being chemicals. So we are going through this just to choke your mind as we prepare for our topic today. But there was something that we are supposed to have gone through, the mechanism through which auxins influence the tropisms. Ndio gani ya kutumia nguvu mingi. Hiyo umeleta wrong. Kuna ingine kweli. So we are going to look at how Auxins influence tropisms. So we want to look at how Auxins can influence some of the tropic movements. In this case, we want to look at just one, and then we can apply to the rest. Now, we shall use geotropism. Geotropism and Auxins. Geotropism and Auxins. Now, for instance, if you have a seedling of beans, a bean seedling, and then you place it in a horizontal position, we can use a diagram, an illustration of this. That's a bean seedling. So the radical is there, and the shoot in that position. And this is the shoot. And then maybe you can hold this bean seedling onto a cardboard using a pin. So if you are going to illustrate an experiment, all you need is a germinating bean seedling, and then you adhere it to a cardboard using a pin in this position. And then what you do, you leave this in a moist environment or in a room, under room conditions. What will happen is this: you realize that after 2 or 3 days, the radical will start growing downwards, while the shoot grows upwards. So this is the observation from this illustration. This is what you are going to observe. You'll observe that one, the shoot grows upwards. Will have bend upwards. And two, the root or the radical that is, the radical will grow. This is the last one. The radical grows downwards. The radical grows downwards or bends downwards. So I want to explain this. What will bring about this observation, explanation? So I'll explain and then we make some note. So what happens is this. We said that Auxins, the source is mainly the shoot and the roots, the root tip and the shoot tip. So this is the source at that point and at that point. So in this position, what will happen is that gravity is going to accumulate or to cause accumulation of auxins on the lower part of both the radical and the shoot. So auxins will accumulate at those parts, the shoot and at the radical. So we said that auxins has two slightly different effects in shoot and roots. In shoot, auxins have stimulatory effect. In other words, in the shoot, auxins will stimulate cell elongation, stimulatory. But in the radical, the root, auxins have an opposite effect. In other words, an antagonistic effect. In the root, it has inhibitory effect. It has inhibitory effect. It's going to inhibit cell elongation at that point. So when we have inhibited cell elongation at this point, it means the upper part of the radical, that part, will have higher rate of cell elongation than the lower part. When this part has higher rate of cell elongation than this side, what will happen? This is going to bend downwards as it continues to grow. It bends downwards. But in the shoot, we have said it has stimulatory effect. It's going to stimulate cell elongation than at the upper point. So we are going to have high rate of cell elongation at the point where we have high accumulation of high concentration of auxins. So the effect is that the shoot is going to grow upwards. It bends upward. So that's why we have this kind of observation. So if we may use a diagram to show the observation that will be made after 2 or 3 days, this is the kind of observation. Radical grows downwards, while the shoot is going to grow upwards. The root. We know that the radical is the one that develops into a root. So explanation to this. We have already said that at horizontal position, auxins will accumulate at the lower part of the shoot and the radical. Auxins accumulate at the lower part of the shoot and the radical. So what is causing this accumulation? Due to the effect of gravity in response to gravity. In other words, gravity is the one that's causing auxins to accumulate at the lower part of the shoot and the radical. Now in the shoot, we have said auxins have stimulatory effect. In other words, it's going to cause cell elongation. therefore causes cell elongation at lower part of shoot than at the upper part. So the effect of this, the shoot bends upward. The shoot will bend upwards. The same is for the radical, but with an inhibitory effect. So that was for the first observation. Second observation, we have the same statement. At a horizontal position, auxins accumulate at the lower part of shoot and radical in response to gravity. So that was the first one. Second now is the same first statement. At a horizontal position, auxins accumulate at the lower part of shoot and radical. But in the radical, auxins have inhibitory effect. Inhibitory effect. Therefore, so because of this, therefore, the lower part of radical, will have low rate of cell elongation than upper part. So the effect of this, the radical bends downwards, or in other words, it grows downwards. And this growth are important. We said as the shoot grows up, it's important because it's going to expose the leaves to light for photosynthesis. And suppose this plant is maybe an angiosperm, a flowering plant, is going to also expose the flowers to pollinators, agents of pollination, if it is insects or if they are animals, if it is wind. But for radical, again, growing downwards, we say it is important because it's going to enable the plant anchor itself, hold itself firmly in the soil, and at the same time, it reach the source of minerals. In other words, it's going to reach the minerals. Now, from these two responses, we are seeing one moving away from gravity, shoot moving away from gravity, and then the radical is moving towards gravity. So we were able to classify tropism into two categories, depending on the direction into which the parts of the plants are going to move towards. If it is towards the stimulus, we were saying it is positive tropism. But if it is away from stimulus, we were calling it a negative tropism. So the shoot is negatively geotropic, while the radical is positively geotropic. The shoot moves away from gravity. Therefore, it is negatively geotropic. Negatively geotropic. It is moving away. And we have said negative geotropism is not a bad thing for the plants, because it's going to enable the shoot now be exposed to sunlight and also pollinators if it is a flowering plant. This enables leaves to be exposed to light for photosynthesis. Photosynthesis is that process by which green plants are able to manufacture their own food. But we have said shoot moves toward the gravity. So because it is moving towards gravity, then we replace negative with positive. Therefore, it is positively geotropic. Positively geotropic. And we have said this positive geotropism is important because it enables the roots to reach sources of mineral ions and also to enable plant hold firmly in the soil. This enables plant to be held firmly in the soil and also reach and also roots reach mineral sources. The only place where plants obtain minerals are actually in the soil. So I think the explanation is very clear. But now, suppose that illustration or that experiment is slightly twisted, such that if that bean seedling is held not just on a stationary cardboard, but on a clinostat. A clinostat is that apparatus that rotates. When it rotates, it means it's going to nullify the effect of auxins. So you can just look at it and see what happens if it was held on a clinostat. Now, a clinostat is that instrument that it has a motor, and that motor, when it is switched on, it's going to rotate the seedling. So if this is our seedling, just in the same position, that's the radical. But now this pin here, we have a clinostat here. That clinostat may be on a board. So what will happen is this: the clinostat will be rotating, and as it rotates, the seedling also will be rotating in that position. So we are not going to have the radical and the shoot in a constant position, but it will be rotating. When it rotates, if we use a 3-dimension like this, if auxins were accumulating at that point and it rotates, you'll realize that auxins will now be distributed evenly in both the shoot and the root. So when clinostat rotates, the observations are not going to be the same as the one that we have previously observed. So here, observations, you realize that there is one major observation for both the shoot and the root. Shoot and the radical will continue to grow in horizontal position. So this is the kind of observation that we shall make. The radical will continue lengthening in the same direction and the shoot in the same direction. Radical in the same direction. So how do we explain this? We have said a clinostat is that instrument. It has a motor and it rotates. When it rotates, because the seedling has been attached firmly using a pin on that clinostat, it's going to rotate. When it rotates, if this is the radical or the shoot, if auxins were at that lower point due to gravity, but now it starts to rotate. When it rotates, what will happen is that auxins will now be evenly distributed. Auxins will be evenly distributed at both the root tip and the shoot tip. So we are not going to have points on the radical or on the shoot where we have high concentration of auxin than the other. So it is going to be evenly distributed, and because they are evenly distributed, the effect, the stimulatory and inhibitory effect, will be uniform. So in the process, the radical continues to grow horizontal position, the shoot continues to grow in horizontal position. Explanation to that, we can take a note together. Explanation. So we have said when the clinostat rotates, it causes the seedling to rotate likewise. So the seedling will also rotate, and as the seedling rotates, distribution of auxins at the shoot tip and root tip will be even, uniform. This causes even distribution of auxins at the shoot tip and root tip. So the effect of this is that the shoot and the root will grow in horizontal position. This leads to horizontal growth of both the shoot and the radical. So in other words, clinostat has done something. it has nullified the effect of auxins. The effect of auxins on the shoot tip and root tip. So it's just like as if this seedling is growing in a vertical position. The same effect can be explained when it comes to light phototropism. Phototropism and auxins. So again, we shall use a diagram just to illustrate what we think can happen. Suppose now you have a seedling growing in that position. In a pot. Let me use one leaf, just one leaf there. And then in this direction, we have a cardboard, and then there cardboard. So it's in darkness, but at that point we have a hole with light, in directional light. So this could be our first setup of the experiment. This is seedling. And then this is cardboard on this side, cardboard on this side, therefore it is in darkness. But we provide unidirectional light at that point. The kind of observations that we shall make, you realize that after some few days, 3, 4, 5 days, this seedling will start growing towards the direction of light, toward that hole where the light is coming from. So again, we can explain that using the effect of auxins. So the observations will be this way. After some time, that plant will have grown in that direction. Maybe after 3 days. 4 to 3 days. So we can try to explain this. So the illustration is this illustration. A seedling is grown in darkness but exposed to unidirectional light. For 4 days. Observation. We have seen that the seedling will start growing toward the direction of light. The seedlings shoot, the specific part, will grow or will have grown towards the direction of light. That's what you have seen in our previous diagram. So it is going to bend toward that direction. So that's what I'm just saying. So the shoot bends toward that direction of light. So I want to explain this explanation. So what's happening? What is causing that to happen? So for us to explain, we are going to use this diagram as the shoot. Now auxins in presence of light, they usually move away from the presence of light. So if this is the direction of light and this is the shoot tip, that's the source of auxins. Auxins are being produced at that point. This light will cause auxins to accumulate on the darker side because we have a shade. When light falls on this object, shade will be at that point. So that's the dark point. So auxins will accumulate, will migrate from this side, the light side or the lit side, to shaded side. So we're going to have high concentration of auxins at that point. But we have said effect of auxins on shoot is stimulatory. It stimulates cell elongation. So if we have high concentration of auxins at that point and they stimulate cell elongation, it means this side is going to grow faster. The shaded area or the shade area will grow faster than the lit part. So in the process, because this one is growing faster than that point, is going to bend towards light. So in the end, you're going to have this kind of response. Because there was high growth cell elongation at this point, and here we had less rate of cell elongation. So in the process, it bends toward light. So we can explain that using statements. When light falls on the shoot tip, auxins migrate from the lit part, to the shade or shaded part. We already know the effect. High concentration of auxins in the shaded part will cause high rate of cell elongation. Will cause high rate of cell elongation. Than on the lit part. So the effect is that the shoot will now bend or grow towards light. Therefore, shoot grows towards light. So I hope that point is very clear. Light falling on this side, the lit part, this part is going to be shaded. So auxins will migrate from this point, and we are going to have higher concentration of auxins on the other side. And because we have high concentration on this side, and auxins cause increased or stimulate cell elongation, we are going to have high rate of cell elongation this side than the other side. So the seedling bends towards light. And this response is important. We call it positive phototropism. This is called positive phototropism. Why? Because the plant part is moving towards the direction of the stimulus, and it's important. Why is it that plants or plant leaves or shoots must grow towards light? We have already given reasons that light is important for photosynthesis. If the plant is going to move towards light, then it's going to expose leaves to sunlight, which is important for process of photosynthesis. So I think these explanations are very clear. So because of that, we can look at a question just to help us understand what we have just gone through right now. So you're going to use a diagram here. So study the diagram. And answer some questions. So we have two diagrams here, the same diagram or the same illustration, day 1 and day 4. So we had a shoot in a box but with a hole, and then just close to the hole there was a source of light. But after day 4, this is what's happening. Still in the same position, the light or the source of light in the same position. So part A of the question is this: name the type of tropic response being illustrated. Name the type of tropic response. We have a shoot. This is still a shoot. So you can answer those questions as you move on. Name the type of tropic response. So we are seeing a shoot bend toward light. Day 1. Day 4, the shoot has grown but is bending toward light. So what type of tropic response is this? Now we have said for us to identify the tropic response, identify the stimulus. What is the stimulus? What is causing change? Or what is the change in the environment? The change in the environment is light. Stimulus is light. Therefore, this type of response is called phototropism. But We said that we have two categories of tropism depending on the stimulus, either negative or positive. So my question is this plant moving or growing towards light or away from light? We can see that it's growing towards light. If it is towards, it's positive. If it is away, it is negative. So because of that, we are not just going to say phototropism. We must be able to classify the type of tropic response either as negative or positive. So for this case, we shall say it is positive phototropism. So the answer becomes very clear because we have included the word positive. Phototropism could be away or toward. If it was shoots, they'll be growing away, so it will be negative. But for this case, the shoot is now growing toward. Therefore, it's called positive phototropism. Another question on this, part B, name the hormone, the plant hormone, that influences the response. We have identified the hormone and it has been majorly one. The hormone is called auxin. Maybe again you can try to give an alternative name for auxin. Can you remember the alternative name? In our previous lesson, we identified alternative name of auxin. Yes, you have remembered? I think your memory is telling you that we said it's also called indole acetic acid. So sometimes it's abbreviated as IAA. So the hormone is auxin. But we say that auxin also works together with another hormone, gibberellin. Leaf enlargement. After the shoot is bending, the leaf will have to be enlarged so that the surface area increases to trap more sunlight. Part C of the question, explain what led to the observation in day 4. Explain what led to observation in day 4 or after 4 days. The best framing will be after 4 days. So we have already given that explanation very well, but we can again go through it. We have said when a shoot is exposed to unidirectional light, if it was diffuse light means if it was diffuse light, we are not going to have this kind of observation. But this is unidirectional, one direction, unidirectional. When a shoot is exposed to unidirectional light, what will happen? That light will cause auxins to migrate from that point which is lit to the dark side or to the shaded side. So on the dark side, we are going to have increased cell elongation as compared to the lit side. When we have increased cell elongation on this side than on the lit side, therefore the shoot will bend towards the direction of light. So when shoot is exposed to unidirectional light, Auxins migrate. Auxins will migrate from the lead side to dark side. So on the dark side, they'll cause increased cell elongation. They stimulate cell elongation. Than on lead side. So the effect, the shoot bends towards light. Bends towards light. Towards light. So I think the explanation is very clear. The other question is the last bit of that question. Dakangape ba? Introduce kingine. Part D of the question. Now suppose this setup is not in this form, but now it's just exposed. Maybe we find another hole at that point, another hole at that point, very many holes on this setup or on that cardboard. You realize that there will be some difference. So we want to use a question to understand that. Part C of the question, D that is. Suppose the seedling was placed in diffuse light. State and explain the observation that will be made. State and explain the observation. So what the question is simply asking is this. Suppose this is the shoot, and then now that containment has several holes and is exposed to sunlight. You put it in presence of sunlight. Light will be coming through that hole, through this direction, that direction, this direction, like that. So what do you think you are going to observe? Now, because there is no unidirectional light, what will happen is that the plant or the seedling will continue growing in a vertical position. There will be no bending towards any side because there is uniform growth. So why is it that the plant will continue growing vertically without bending to any side? It is because we have diffuse light. Diffuse means light in all direction, even distribution of light. There is light above the shoot, light on this side, light on that side. So for that purpose, because we have diffuse light, we are going to have uniform distribution of auxins. There will be uniform distribution of auxins around the shoot tip. Once we have that uniform distribution of auxins around the shoot tip, then it means the rate of cell elongation will also be uniformly distributed around the shoot tip. If we have uniform cell elongation, rate of cell elongation, it means the plant will continue growing in a vertical position. So in form of a note, we can say diffuse light allows uniform distribution of light around the shoot. So because of that, this causes uniform distribution of auxins. And we know the effect of auxins is cell elongation. Therefore, leads to uniform cell elongation. There will be uniform cell elongation around the shoot tip. Cell elongation in the shoot tip. In the shoot tip. So because of that, the plant will grow vertically. The seedling will continues to grow vertically. Then the last question, we can also look at the effect of the two hormones, just to remind ourselves. Question 2, state the effects of the following hormones, of the following plant hormones. Auxins. So this is very easy because we have we have looked at it in details, the effect of auxins. We have pointed out one thing, that the major effect of auxin is that it is the one that stimulates cell elongation or causes cell elongation. Now remember the circle of the cell through which the plant cell will go. If we have a cell, first thing, if it is at the shoot tip or root tip, sometimes meristematic tissues, one thing that happens is cell division. It's going to divide. We have a cell, it divides. Let us just say, use binary scheme. It's going to divide, cell division. But after that, it's not going to remain in the same size. The same size is the size is going to change. It's going to elongate. It elongates. So it is this elongation that brings about growth. Elongation. So it is the major one. But cell division, you are just increasing the number of cells. But cell elongation, the number of cells remain constant, but what happens to them? They increase in size. What can bring about that? Because cells are taking in water and other nutrients. So as they take in nutrients and water, there will be cell expansion, which brings about cell elongation. Then after that, just a reminder of cell circle. After cell elongation, the cell will start dividing, differentiating, that is, cell differentiation. If this was just a cell like that, it becomes, maybe it forms a root hair cell, something like that. That's modification. It has been modified, cell differentiation. Cell differentiation. After cell has differentiated, it becomes mature. It becomes permanent. The same cell, but it becomes mature. So it was it was one, it divided, or there were a few, they divided, cell elongation, they took water and other nutrients, there was some expansion. After that, there is differentiation, so that now it can perform specific functions, and then it matures. But where we are is at that point, cell elongation, where auxins are very important. And then B, gibberellins. Gibberellins also works together with auxins, but it has several other functions. One of them is causing root growth. It causes growth of the roots. And then another one, enlargement of leaves. After leaves have been formed in the shoot, there will be enlargement of leaves, which is important so that it increases surface area for trapping of sunlight and also for gaseous exchange. Remember, carbon dioxide is very important in photosynthesis, the major raw material. And then flowering causes flowering in angiosperms. Angiosperms are a type of plants that usually produce flowers. But remember, after formation of flowers form not for purpose of beauty for the plant, but as a reproductive cycle. After flowers have been formed, there will be pollination, fertilization, and then fruit formation, seed formation. When a seed is maybe dispersed from the plant, it will now again germinate into another plant. So flowering is a very important part of the cycle. So after flowering, there is fruit development. So again, gibberellins comes in, causes fruiting in plants. So I think we have understood very well how plant hormones take a part in plant responses. So then, in a nutshell, we should remember that plants being less active and then being less complex, they do not respond to changes in the environment at a faster rate. But the major factor that brings about those responses in plants are plant hormones. And the major sources of plant hormones are the shoot tip and the root tip, with very major emphasis on auxins. So thank you for listening. Welcome even more for more lessons as we continue.